Welcome to this last session of today's conference. I apologize in advance. This is in English. The slides are in English as well, so I do apologize. I've already apologized to the translators because I'm going to earn their money, as I am going to go through quite a lot. I'm going to start off with some economics. From economics, I'm going to do a bit of history. From history, we're going to start looking at the current supply chain. We're then going to look at what's happening in technology across the supply chain, and then it's going to end up with a projection into the future, all in about 45 minutes. So hold on to your seats. Let's hope this works. I did have a real issue with this. I've been panicking. For those of you who know me, I've been sweating quite a bit because there's a lot of videos in this. We're going to be going through showing lots of examples. And I was rather unaware that Turkey had banned YouTube. And given that I've got 14 YouTube videos throughout this presentation, that was a bit of an issue for me yesterday when I realized none of it worked. But luckily, the gods have signed, and it's working again right now. So unless they stop it halfway through the presentation, in which case we've got a problem. So, you ready? Okay, anyone here economist? Anyone done economics? Yep. You may recognize this guy, Nikolai Kondratyev. He was a Russian economist who was recruited by Stalin to prove that capitalism was going to fall at the Great Depression. And he did his work and said, no, actually capitalism goes through cycles, peaks and troughs. And Stalin didn't like what he said, so he sent him to the Gulag and then killed him. Okay? But the reality was, he was correct. And as we can see, these Kondratyev waves, K waves, as they're told, they move. And we have these peaks and troughs, and we've just come out of one. Now, his work was taken over by this gentleman, Joseph Schumpeter. And he actually said, these waves are caused by innovation, by the creative destruction of industries. So we destroy the old industry to create. Innovation marches, it does not stop, it progresses. And entrepreneurship that capitalism frees creates this innovation. It allows people to make profit through developing new ways of working. And you can't stop it. Once you have a capitalist society with the right social and economic platforms, this will continue. And these waves were broken into cycles. And here when we have prosperity, you know, when the job market grows, we have new innovations, it grows the market, inflation rises. We then hit a point where, like a product life cycle, where the market decreases. We become more focused on efficiencies, looking to manufacture things more cheaply. Borrowing increases. Then the industry crashes. It hasn't happened recently, of course. You know, jobs are lost, debt bubble bursts. And then finally, this creative destruction kicks in again. Capitalism finds a way. And we're seeing that at the moment with the development of crowdsourcing, with Kickstarter, with Bitcoin. You know, it will find a way around the restrictions that are placed on it. New industries are created, new jobs are created, but the destruction of old industries. So if we look through history at what that looks like, so if we look at creative destruction in the history of the supply chain, you know, it moved from agriculture to industry. You know, in the United Kingdom, up in the northwest, where the steam engine and mechanized milling started, and it moved through production efficiencies to say we can actually use power, and this was unique to the social and economic environments that existed in those countries, because only in those countries was capitalism free to profit, where people could look at a falling amount of water. And rather than see, like the Chinese, something just purely of beauty, to actually think, I could generate some power from that. If I put a mill at the bottom of it, that would crank an engine, that would... So only in those environments where the social and economic structure existed. But once that started, it then moved forward, and mass production was created. And then it created a completely new discipline. Management. We never needed to manage people before. Everyone was concerned only with feeding themselves and feeding their families. Now suddenly we're bringing people from the country to the city, and we need to manage them. So Frederick Winslow Taylor, process of scientific management, management became a process. We talked about electrification happening. Henry T. Ford took a look at the abattoir, the disassembly line, the breaking up of carcasses, and thought we could re-engineer that into the assembly line. So then mass production was created. And it created a different type of job that didn't exist before. The job on the production line. where effectively people became like robots. We do one thing repeatedly, and we build efficiencies at that. And America led the way, up until the Japanese got hold of it. And then they did it better, much better. And they actually realized that there were cultural aspects of getting people together. So things like Kaizen principles, of actually quality circles, of realizing that every individual is not just a robot. They actually have a contribution to make. They could be an asset to the organization. They could work together to identify how to make processes better. And that destroyed the American car industry because the Japanese car industry took over. So again, this creative destruction continued. And then in the 1980s, we rethought the whole process of business. The computer age was born. Suddenly, the office became automated with the development of computers. We had concepts like material requirements planning being generated, realizing that actually there are different functions that need to work together to get a desired output. Michael Porter in 1985 came up with 1985 came up with the concept of the value chain. These processes need to work together in an integrated way. That was then picked up by Hammer, who then said we can re-engineer the business. Luckily for him, along came technology to enable this. So big ERP implementations suddenly were de rigueur to re-engineer your entire business. And then you had the Y2K issue where everyone thought planes were going to drop from the sky and the world was going to end. So yeah, everyone went into SAP, went into other ERP systems and looked at re-engineering the end-to-end enterprise. Which led us to the 2000s and the dot-com boom. And suddenly the world starts to connect. We have people like Thomas Friedman who said, globalization is here. The world is flat. We will now be able to communicate and trade countries like Turkey, in the same way as we can trade with the company down the road. We have new social media platforms that allow people in different time zones to talk to each other. And then it all went a bit wrong. Around about 2008, and the debt bubble collapsed. But we're in a world now where effectively we're all connected. I stand here in Turkey talking to you in English. People understand each other. We connect. I've had LinkedIn requests from people already. We connect. Which finds us in 2014, where we have a completely integrated global supply chain, effectively, wirelessly communicate and linking demand and supply together. But what's that supply chain really look like, and what actually has happened, and how much has really changed right now? Because one of the issues that was identified about these Kondryat waves was the social and economic platforms that needed to exist to enable it to happen. So in the United Kingdom and the United States, the Industrial Revolution took off in the 18th century. In the emerging countries, they're now effectively taking off now, albeit with new technology, but ultimately going through the same process because the social and political framework exists for this to happen. Which means that ultimately you have curves that intersect. And what happens is the companies that are and the countries that are at the front of the curve, when they reach their peak, they're looking for efficiencies. They're looking to sweat their assets more. And they're looking to see where they can actually do things cheaper, which has meant there's been a huge move to outsource and offshore into China, to India, to Brazil, to the BRICS, the Mint countries, of which you're one of them, looking to say, how can we do this cheaper? So our supply chain, end-to-end supply chain, however, has been experiencing difficulties because the people at the front of the curve have moved on. And they found that actually they're not too happy with people in working conditions that were fine for 150 years ago when we knew no better, but not so good nowadays. So we have Tasmanian miners who are dying in the ground, digging stuff out. You've got your own people protesting about working conditions that probably wouldn't be acceptable in other countries. We still have children, child labour, something that the United Kingdom eradicated 150, 200 years ago, but still exists in other parts of the world. And capitalism is profiting from that. and you migrant workers who move to North America to do things, to do boring, dull, or dangerous jobs cheaper than everyone else. When we move to goods, we want to move goods around the world. We've got pilots striking. This is fantastic for me because it's very English that this plane almost crashed because the pilot and the co-pilot were both asleep. And the words were, "Crikey, that wasn't good," just as they were about to land. 1 of 6 pilots admit they've fallen asleep when flying because the volume is increasing. The job has become from a very highly skilled pilot to you're a glorified taxi driver. Volume now. Most pilots fall asleep on duty. Freight travel, moving stuff around the world constantly. This is really interesting. The Human Error Marine Society report. Shipping accidents, 84 to 88%. Human error, 79% towing vessel ground. Human error. Human error is the vast majority of reasons why we have issues at sea. Let's go to manufacturing, to the make processes. Well, you remember this from last year, this collapse in Bangladesh. So many people liked the cheap T-shirts. They weren't too happy when they found out that, 1,100 people and 2,500 people died because one building came down, which gives you the scale of people who worked in that space. So suddenly it was an outrage because, we've got companies who, we buy from every single day. We don't realize this, but we're not happy about that. Scenes like this stick in the memory. And we've also got Apple, for example. It's recently come into some bad stress because of its supplier, further down the supply chain. Same with Samsung. We might not go out into the Amazon because labour's really cheap out there, but we treat people in a way that was not acceptable in the first world. 17 suicides at Foxconn, the major manufacturer for Apple. The first reaction, because they realised all these people were jumping off the roof, was to put nets around the building. Not so good. I'll come on to what the second reaction was soon. But the bad press, the PR damage, the corporate social responsibility implications are enormous. And brand damage. So protests like this in New York, just don't do it against Nike for the practices of the manufacture of shoes. Let's look at the deliver process. So we've made some stuff, we need to get it to you, to the consumer. Amazon, which has vastly taken over pretty much every aspect of the retail experience. Treating people like robots, pushing them to the limits, 15, 16 miles a day they're walking. This is not in a third world country, this is, over here it's in the Seattle Times. Germany, the UK. People saying, you're treating us like robots. I don't happy. The working conditions here are not good. And then we pick this stuff and we put them in the trucks. But again, human error, because of the vast quantity of goods that are moving across the country. Main cause of traffic accidents in Turkey. Main cause of rail accidents in India. Main cause of road accidents pretty much everywhere. Human error. And if we look at these two pictures that were 100 years apart, they look pretty similar. They're no different. So we have the industry at the front of the curve, basically using the workers at the back of the curve in the cultural lag to do exactly the same job. However, the countries at the front of the curve are not happy about this. The consumer suddenly has a voice through social media to protest and to vote with their feet. So what's the solution? What are they doing about it? Well, welcome to Supply Chain 3.0, the beginning of the 5th Conrad wave, or as I like to call it, the second automation revolution. So let's look again at that end-to-end supply chain. Let's look at suppliers. Let's go back to the fields and where they dig stuff out. So here's the world. We'll start in America. So we talked about the migrant workers coming in from Mexico and the cheap labour sources. Let's see what's happening now.
In a region known as America's Salad Bowl, it's training day for the lettuce bot, an intelligent machine designed to thin rows of budding lettuce plants.
And the nice thing about lettuce bot is that it does it automatically, it does it very fast, and it does it in a better way with more information than a human can.
so you can look.
The lettuce bot is still in development, but it can already thin a field in the time it takes about 20 workers to do the job by hand. That could be a boon to farmers in California's Salinas Valley, which ships leafy greens to supermarkets across the country.
Labor is getting more difficult to find, and having something automated like this can reduce the amount of people we need to do a field.
The lettuce bot was created by engineers at this Silicon Valley startup, part of a trend to develop robots to do the most tedious farm work.
They can take repetitive tasks that are just very boring and simple for a human to do, and do it effectively, fast, and accurately.
These engineers are teaching the machine how to recognize lettuce buds, then decide which ones to eliminate with a squirt of fertilizer. Blue River also plans to develop robots for weeding and eventually harvesting crops.
We are one more step in a very long series of steps that have been taken to first mechanize and now automate agriculture.
The future of farming now riding on the wheels of robots. Terry Che, Associated Press, Salinas, California.
So we had a job which employs huge amounts of migrant workers to do incredibly boring work, but creates employment. Suddenly it's saying, well, actually we can use robotics to do this. It's dull, it's work, it's repetitive work. We can use robots to do that. One of the things you also saw earlier was mining. Mining being a very dangerous job, where lots of people have lost their lives. Mining conditions out in specifically Africa, and I know it was also in Turkey, not very good. People lose their lives. What's happening with that? Well, let's go to Australia. So Rio Tinto, probably the largest mining company in the world. This is a control centre in Perth. These people control an entire mining operation that's 1,500 kilometres away. The people who control it have never been there. These mines, each one of those vehicles does not have a driver. They are picking stuff out of the ground, they are loading it onto trucks, they are moving it to a train, and they've just spent £500 million spending on an automated driverless train system that takes them directly from the mine all the way across Australia to the docks. Not a single person is involved in that process. It's controlled from 1,500 kilometres away. These were the highest paid miners in the world. They were paid the same as surgeons in the US. Their jobs have gone because innovation has found a way to do things cheaper and better. I'm going the wrong way. Now, we saw earlier lots of pilots falling asleep.
Boeing test pilot Jason Clements goes through final flight checks in the cockpit of an F-16.
Just make sure my switches are set in the right position. The throttle is free and clear. Lights are on.
Shortly before takeoff, with the engines whining and a cockpit cooling system blowing at its max, Clements exits the cockpit. He then closes the canopy via a remote switch. In a matter of seconds, the aircraft, with its burner lit, roars into the southern sky headed out over the Gulf of Mexico. While in the air, the unmanned QF-16 reaches an altitude of 40,000 feet, a speed of Mach 1.47, and engages in aerial maneuvers such as a barrel roll while pulling more than 7 Gs. F-16 and F-4 chase planes off the port side follow the QF-16 as it makes its final approach back to Tyndall and picture-perfect landing.
So that was September last year. The interesting thing, we talk about drones, autonomous flight vehicles. That was a retrofitted F-16. Now you're telling me they're not going to be able to retrofit freight planes, passenger planes, to do away with all of these nasty human errors? Rolls-Royce, earlier this year, unveiled their plans for unmanned ships. So we saw that 80 to 90% of all shipping errors were caused by humans. Rolls-Royce is currently working on a way to say, let's take humans out of the equation. And when the stuff actually arrives at port, this used to take huge volumes of people to move stuff off ships, but then containers came along, which automated to some extent. But what's happening right now? Let's have a look.
Giant robots.
This is Holland.
Almost every machine you now see is controlled by computer. And these high-tech titans' output is staggering. Each loading crane can deadlift 40 tons. Below, the container's chariot awaits. Called an Automated Guided Vehicle, AGV, this car has a mind of its own. Literally. There's no driver because an onboard navigation system regulates its position, direction, even speed by a magnetic grid set into the tarmac. Once the container is loaded on the AGV's back, top-mounted infrared eyes ID the container and instantly roll the load to a preset stacking location, where another giant robot takes over. The stacking crane. Towering 5 stories in the air, this mega machine can grab, haul, and drop the equivalent of 5 school buses. Like the AGV, she takes orders from no man. Every move along her magnetic track is totally pre-programmed, just like the other 37 cranes. And 370 robotic cars.
Stop it there. So once the goods arrive at port, now, that was Holland, they're looking at automating the entire port process. So we've potentially, machines pick stuff out of the ground, machines move stuff to port, machines put stuff on ships that don't have people, that arrive at ports where machines take it off. What happens when it gets to manufacturing? Anyone seen this before? This is Baxter. This came out in September 2012. It's now on release 2.0. Yeah. Meet tomorrow's workmate.
Meet Baxter. Baxter is Rethink Robotics' flagship product in a revolutionary new category of robots with common sense. Baxter is a low-cost and highly adaptive robot for manufacturing applications and is so easy to use that non-technical workers can train it. Baxter increases workforce productivity so that factories can compete with low-cost offshore labor. And Rethink Robotics practices what it preaches. Our robots are made in America. Baxter can do manufacturing tasks like material handling, line loading and unloading, test and sort, machine tending, packing and unpacking, light assembly, and finishing operations. Baxter is a complete system requiring no integration. It can be uncrated and doing useful work in under an hour. While traditional manufacturing robots need to be programmed by expensive technical professionals, Baxter can be trained by non-technical personnel. Train Baxter to do a new task by just showing it what to do. No application software or teach pendant is required. So the people working with Baxter get a promotion from working on repetitive mundane tasks to supervising robots that do them. Baxter has a suite of integrated sensors and the common sense to work intelligently. It adapts to the speed of the conveyor and variation in part placement and does human-scale tasks at human cadence. So unlike traditional automation, there's no need to redesign your workflow to accommodate Baxter. Baxter safely operates elbow to elbow with people. Its unique compliant mechanical architecture lets Baxter give on contact. Baxter is an extensible platform like a PC or smartphone. You get regular software updates with new capabilities. Baxter is showing up everywhere, at small manufacturing firms that couldn't previously afford robots, and at large firms, rethinking processes that weren't previously economical to automate. Rethink manufacturing. Rethink offshoring. Rethink robotics.
How much? How much for Baxter? 30,000 what? Half it. $14,000. About the same as a minimum wage person in the US, only doesn't need holidays, doesn't need unions, doesn't need to sleep, doesn't need to stop. So you're talking about no unions, no regulations. No. They're looking at this. Manufacturing is going back to the US because this is cheaper, and also you don't have to worry about fuel prices. You don't have to worry about transit costs. You don't have to worry about supply chain risks. So you're localizing again manufacturing. Manufacturing's going back, not the jobs. So maybe we're in a world where maybe robots and humans could potentially in the future work together, side by side. Or maybe they do it already. This is Japan.
High tech.
Given Google's new self-driving cars, the increasing use of automated software to grade college essays, and the unmanned CIA drones striking targets in Pakistan, perhaps these robotic factory workers shouldn't come as such a surprise. The rise of the robots might terrify most, but here in Japan they're making a positive impression on their work colleagues. It's nice, it's like a human being. He's cute. Built by Kawada Industries, these humanoids work alongside their Homo sapien brothers to manufacture ATMs and ticket machines. Known as Next Age employees, they have been accepted as important, even inspirational members of the team. He works with more accuracy than us, but it motivates us. First constructed in Tokyo 5 years ago, not far from this factory, Next Age is an employer's dream. It has a fierce work ethic and shows no signs of fatigue. It can work around the clock for a period of 3 to 5 years with no holidays, and it is never sick. Next Age works tirelessly, accurately, and without complaint thanks to the specific computer code that is its DNA. In fact, it's not too complicated. We already have a blueprint for every movement. We just select these patterns and stream them from end to end. Whilst the robot's humanistic features are probably helping prompt orders, the fact its €30,000 fee can be recouped in just a few months is also part of the appeal.
That makes me laugh a little bit where the woman goes, they inspire us, they're so much better than us. China has been growing exponentially, mostly because it has 1 billion free people to do what we used to do 200 years ago in the same way. China's woken up to this very quickly. Robots may revolutionize China's electronics manufacturing. Do you remember I showed you Foxconn, where people were leaping off the roof because the working conditions were so poor? Foxconn obviously took this very seriously because Apple and the other companies leant on them and said, this is not good, we do not want these headlines. So it's replacing pretty much its entire workforce with 500,000 robots. That's quite a lot of people out of a job, replaced with robots. They are quite a way. They're actually speeding up their deployment. By the end of 2015, they will have all 500,000 operational. Also in manufacturing, we've got additive manufacturing, otherwise known as 3D printers, which is changing the possibilities in terms of manufacturing. So we have Nike, developing footwear. It's vapor footwear using 3D printed parts, clothes. Originally, it was all plastic, and resins, but now we have spare part components, manufacturers doing away with suppliers and saying, I don't want your long lead times. We will just make the bits as we need them. On site, we can 3D produce with metal. So there's, metals. We do it at a biological level at the moment. They're looking at lung replacements and organ replacements using this additive manufacturing technique. There is obviously risks and issues. At the top there you see a metal gun that's been produced via a 3D printer. So only a year ago they had that white plastic version that everyone was getting upset about. Already produced homemade metal weapons. So the whole manufacturing process is potentially going to be turned upside down. We're now cars and manufactured, this particular company here is now looking at producing cars in one unit, one 3D manufactured unit, which again completely changes the possibility. So they're rethinking the manufacturing process using, technology. And we think about 3D printers as being something small that sit on desks that produce little pieces of plastic. But BAM, big area additive manufacturing, these are industrial-sized machines that can produce industrial-sized components using 3D printing technologies. And I was going to show you the video on this, but for time I won't. They're now 3D printing houses in a day. And in fact, China printed 10 houses in a day using a more sort of modular approach, whereas the other one used a continuous build mechanism. Now, there is a lot of really good opportunities here in terms of, when there's disasters hit, when you're talking about replacing slum buildings with this, but also talk about creative destruction to the building industry. When you print houses that already are pre-wired and they all have the slots for the plumbing that just goes in. What's happening in the deliver side? Seen these? Kiva bots? Have a look at this. This is the warehouse. This is what's happening in the warehouse.
Their formal name is Mobile Robotic Drive Unit, but more affectionately known as the bots. It occurred to me through a series of brainstorming exercises that what if the inventory could actually walk and talk? That quickly led to the notion of mobile robots carrying mobile shelving and really just setting the inventory free. This particular robot has delivered a pod to the station that's inside of a queuing system, and now it's being told by the host to take the load back to storage. What we ended up doing was just laying down a grid pattern of stickers on the floor, and we asked the robot to travel on those stickers. And so the robots are having a wireless conversation with the host that's directing the traffic. The inventory figures out where to store itself.
About 50,000 square feet of our warehouse is designated as Kiva storage location. We have over 300,000 units of inventory currently on the Kiva floor. This is one of our picking stations. The laser and the touch screen is going to tell our associates here what units to pick and then what order that unit corresponds to. Each blue tote represents a customer order, so we're picking 17 customer orders simultaneously. The system is dynamic enough that it knows which SKUs are selling the most. So it keeps those pods close to where the action is. It keeps our associates productive during their entire shift, as opposed to spending 2/3 of their day walking aisles, seeking out customer units, or looking for empty locations to put away merchandise. They're right at their station with predictable outputs, and they're constantly working for us.
The starter kit for Kiva for a small .com retailer might be a $1 to $2 million two-station, couple hundred pods, some bots. The sweet spot for our customers seems to be in the $4 million to $6 million range. That's a typical capital deployment, but then of course we're selling a lot in the 10 to 15, and we've got some customers with $20 million of Kiva equipment under one roof. The human here is very vital to the actual manipulation of the inventory. In the Kiva model, the human in the loop is very important for what we're trying to do is augment the human by eliminating all their wasted time and motion.
Just watching how they communicate with each other behind the scenes so that they're not crashing into each other is really something that's just overwhelming at first.
They're very fun to watch, and we're having a lot of fun as a company bringing this solution to the market.
So the whole warehouse operation effectively automated, where the inventory comes to the person. And if you research Kiva a little bit, you'll find that they've got elevators, they've got multi-tier storages. You've heard that it dynamically understands what's selling and what's not selling, so it moves the stuff that's selling frequently. They had 17 orders on the go, so the lasers were basically pointing and saying one of those there, two of those there, and allowing the pick person not to go and have to chase stock. Now, one of the companies that got an enormous amount of bad press, you may remember, for the conditions in their warehouses was Amazon. Amazon bought Zappos.com. Zappos.com was one of the companies that had this. Amazon took one look at that and bought the company. So all these pesky human workers that keep giving Amazon a bad press, so once we've actually picked stuff, we need to put it on a vehicle. The vehicle needs to go to the customer. I love this picture, but I also have a great regret about this picture, because this, you'll recognize here, CEO of Google, and the governor of California signing the approval for Google autonomous cars to legally drive on their road. And I really wish that Arnold Schwarzenegger was still the governor of California at that point in time, because the Terminator signing the papers that allows robots on the road would have just been fantastic, wouldn't it? It really would have just been fantastic.
Ladies and gentlemen, you are about to witness for the first time on any screen a preview of things to come in your car of tomorrow.
Ah, old visions of futuristic cars. First cruise control, then cars that park themselves, and then ones that helped you avoid fender benders. But now...
And now it's driving again.
A self-driving car. And from, of all companies, Google.
It uses cameras inside to spot traffic lights and other things. And also uses this thing on the top, which is a scanning laser.
They say this car's already driven itself 140,000 miles. Driven itself? Really? Here's how it works. You tell the car your destination, it plots a route, it's aware of speed limits, traffic patterns, and known obstacles. So the wheel just turned completely by itself?
Completely by itself.
It's not intended to replace drivers, but to help them.
It's like, super cruise control.
Imagine clicking the button for auto drive when you wanted to dial a phone number or read a text.
If you wish to drive it, just fine. If you wish to waste 52 minutes in commute traffic, go ahead, be my guest.
In fact, Google touts safety as their motivation. They say this technology could one day cut traffic deaths in half. Whoa! It got really nervous.
Yeah, it must have thought it saw somebody coming in down the on-ramp.
So how does it handle stop signs and alternating turns with other cars at intersections? Crosswalk ahead.
It would be the same probably with pedestrian safety in the sense of using the radio signals to check and see who's in front of them, who's around.
But how does it handle the unexpected? How about a little game of chicken? It stopped. But I was really scared it wouldn't.
My hope is that we transform society to make traffic safer, more efficient, and also more pleasurable.
That video is about 18 months old. Google has now done about 700,000 miles with their cars. And they've recently tested it in a place in the US where they've lots of construction work, lots of things that aren't on the map that's happening all the time, to test it in those kind of environments, not just the freeways. It kind of works. All the major car manufacturers are looking at autonomous cars right now. So by 2020, these will be a familiar sight on our roads. Now, you mentioned in there, hey, these are not to replace the drivers, these are to augment the drivers, these are to make driving more pleasurable, so et cetera, et cetera, et cetera. And then you see headlines like this. 6% of the US population works in a driving job. Not for long. Okay. But it's not just cars. Logistics. This is Volvo's Project Satra. I was going to show the video again because of the time I'll constrict it down. But they use something called platooning, where they have a lead truck, and it wirelessly communicates with all other vehicles behind them, be it cars or trucks, who follow it. And they keep a really close gap together, so the carbon, the emissions are really low, and the coefficient drag's really low. So basically, the only person that's got a driver is the truck at the front. So you're going to imagine these trains of vehicles moving around the country. You know, and the savings that brings in terms of, you know, fuel efficiency savings, in terms of driver costs. You don't have to have a tachometer to say you can only drive so many. I don't you have them in Turkey where you can only drive so many hours legally? Gone.
Then on 60 Minutes, we got a rare look at the way Amazon does business.
What about this?
The world's largest online company tells us how it delivers to 225 million customers around the world. Founder and CEO Jeff Bezos is taking the company's need for speed to new heights.
During our visit to Amazon's campus in Seattle, Bezos kept telling us that he did have a big surprise, something he wanted to unveil for the first time.
Let me show you something.
Oh, man. Oh, my God.
These are octocopters.
Yeah.
These are effectively drones, but there's no reason that they can't be used as delivery vehicles. Take a look up here so I can show you how it works.
All right. We're talking about delivery here.
We're talking about delivery. So there's an item going into the vehicle. I know this looks like science fiction. It's not.
Wow.
This is early. This is still years away. Drops the package.
There's the package.
You come and get your package. And we can do half-hour delivery.
Half-hour delivery.
Half-hour delivery. And we can carry objects, we think, up to 5 pounds, which covers 86% of the items that we deliver.
And what is the range between the fulfillment center and where you can do this within 30 minutes?
These generations of vehicles, it could be a 10-mile radius from a fulfillment center. So in urban areas, you could actually cover very significant portions of the population. And so it won't work for everything. You know, we're not going to deliver kayaks or table saws this way.
Right.
These are electric motors, so this is all electric. It's very green. It's better than driving trucks around. This is all an R&D project.
With drones, there's somebody sitting somewhere in front of a screen.
Not these. These are autonomous. So you give them instructions of which GPS coordinates to go to, and they take off and they fly to those GPS coordinates.
What's the hardest challenge in making this happen?
The hard part here is putting in all the redundancy, all the reliability, all the systems you need to say, look, this thing can't land on somebody's head while they're walking around their neighborhood.
That's not good.
That's not good. You know, I don't want anybody to think this is just around the corner. This is years of additional work from this point.
But years means 5, 10.
I'm an optimist, Charlie.
Yeah.
I know it can't be before 2015 because that's the earliest that we could get the rules from the FAA. My guess is that's probably a little optimistic. But could it be, you know, 4 or 5 years? I think so. It will work, and it will happen, and it's going to be a lot of fun.
With the drones possibly taking flight in the not-too-distant future, Amazon is raising the stakes in the race for faster delivery.
Amazing. Quite amazing.
Yeah, incredibly amazing. I mean, it was a great piece. The question I have is, I mean...
We'll move on. A lot of people thought this PR stunt. He ain't serious. He was, and he will. They're investing quite a lot in this. With the legality side of this, obviously, is one of the big things that has to be overcome. The same with autonomous cars. It's a hurdle. They'll get over it. What about consumer? This is Korea, South Korea, not North Korea, because you can't see images from North Korea. That's a train. This is a train station. That's people boarding a train. This is Tesco, Home Plus model, virtual stores, where they did it on the subways and then they moved it out to the universities and put it on the bus stops, where people simply just purchase off a segmented choice of product and place your order. And they said within 30 minutes of you getting home, your product will arrive. Probably on an autonomous truck or a drone. Anyone seen these before? What are they? What do they look like? Vending machines. Boring. How interesting is a vending machine? Coke Freestyle and Unilever Share Happy. Very quickly, Coke Freestyle. You buy your drinks normally from a fountain. It has a choice of 4 to 6. Now there's 120 product variations using pharmaceutical microdosing technology. What's really going on here is that you can use any combination of drink, and that thing knows where it is. It knows what inventory it got. It replenishes itself. It tells Coke when it's running low on stock. It also tells it what people are buying, in what combinations it's buying, and where it is. So suddenly it will know that consumers in Atlanta who are having pizzas like mixing Coke and Fanta. Consumers in New York who are having burger, like Sprite. So it's real sense and respond information being sent. But we have to manage that information. Likewise, this has been released. Amazon came out last month. Amazon Dash. Barcode scanning, voice recognition, amount of chocolate chips, amount of guitar strings. It automatically builds an order on their website for you, and then you just simply go on. It's been released, it's been trialed with Amazon Fresh, their retail arm. It's been a massive success. The consumers love it. So we're tracking all this information. But we've got to store it somewhere. This is where the cloud comes in. This is enabled. This is a creative destruction that's enabled this. So big data is one of the things that we talk about a lot, the ability to store this and take this information. Information is the new resource of the future. But it has positives and dark sides. All this data then has to be crunched. We can feed it into our ERP systems. We can use it to drive procurement, drive manufacturing, drive all of these processes that people used to be involved in. SAP releasing things like HANA to be able to crunch these kind of volumes. So what's really going on? What's happening here is actually things are speeding up. Creative destruction is getting faster and faster and faster. There's a new record of industrial robots now. Companies are working out this is better than people. It's cheaper, it's more efficient, it's less dangerous, and it's destroying industries. Google is working with Foxconn on robotics. Google bought 8 robotics companies last year, including Boston Dynamics, the US military robot company. They're also working heavily on artificial intelligence. They're also working heavily on anti-aging. 2 companies, Google and Amazon, have the potential to disrupt pretty much every industry on the face of this earth because of what they're doing right now. Moore's law. You're all aware of Moore's law. Every 2 years, transistors are, half in price, double in power. This is what's driving this, and it's getting faster. So, for example, in 2005, these two professors, professor from urban economics at Massachusetts, MIT, and a professor from Harvard, said, this is amazing, technology, computers can do all these wonderful things, but there are some things it just will not be able to do, like drive trucks, drive cars, because it's too complicated. I think we just saw they might be wrong on that one. Yeah. So suddenly, 5 years turns into an absurdity. What was a certainty in 2005 is absurd now, because in 2010 we had robot cars. And we see images like this of how we take something big and bulky and put it in our pocket. 3D printing. Business opportunities. Again, at the moment, it's rapid prototyping, molding and tooling. It's going to move into manufacture and fabrication really, really quickly, and it's going to disrupt manufacturing from top to bottom. Already there are shops allowing people to make their own stuff and trade amongst themselves.
Since the beginning, the progress
I'm going to have to skip this, I'm afraid, because I'm getting signals from the back that says if you don't get off stage really quickly, you're going to have a problem. Take a look, if you go on site, have a look at Meta space glasses. This is where they're actually developing things using sort of Iron Man technology. They're out this year where they don't even physically exist. Phones, laptops don't exist. They're actually built into the headset. So you effectively dial numbers, use things without them. They're trialing them now. They're available for sale in a month. This is the whole Iron Man, move your fingers around, grab things. And what they're actually doing is they're able to model things, move it, put it onto a 3D printer, and then print the physical object from something you've just created out of thin air. The Internet of Things. Basically, we're talking about dumb objects, things that just a fridge, a vending machine, becoming intelligent and talking to each other. So is this the beginning of the end for mass marketing and mass production? The future supply chain will be personalised. Consumers are going to become creators. Mass production will be by customisation. I'm not happy just getting a one-size-fits-all. I will use technology on the internet to develop my own version of this. And they become localised. Production will move to the consumer, either in their house. 3D printers will become as ubiquitous as normal printers, microwaves. Or potentially for larger items into these big additive manufacturing sites. So all this move stuff around the world, we ain't going to need to do that anymore. And it will also become completely automated. So at the moment, we talk the worlds where we've got a pick worker, with stock coming to him. But how long before we say, hey, why don't we just put Baxter there? Let Baxter do the picking. In fact, why don't we just let the robots build the robots? And already, they're moving into the service industries. Robots recently did 360 burgers in an hour. So there's other industries have been looked at and said, hey, we can automate that. The technology bubble in Silicon Valley is looking at industries and going, we can make that better. What's the social and economic impact of that? That's the really big question. So effectively, is the future supply chain a human-free zone? I did want to go on to, and I've missed my timing terribly, and I've just got the organiser saying, get off, in a very aggressive way, but the social and economic impact potentially of this, and the positives and the negatives. But I'd like to leave you with this at the moment. The whole world, the creative destruction nature of the world means that this is going to happen. It's happening right now. It's going to happen really, really quickly. Is your business ready for it? Thank you very much.
Thank you.